When did the dinosaurs arise on Earth? What were some of the first dinosaurs? How and where did they live? Join us as we discover the history of the first of the mightiest beasts the Earth has ever known, the dinosaurs. Megalosaurus. Megalosaurus bucklandi was the first non-avian dinosaur to get a systematic name still used today. In 1824, British scientist William Buckland, Professor of Geology at the University of Oxford and Dean of Christ Church, described it from just a broken piece of lower jaw. Megalosaurus's name is taken from the Greek megas, which can be translated to big, tall or great, and sauros, meaning lizard. Together they mean the great lizard. The species is an extinct genus of large carnivorous theropod dinosaur of the Middle Jurassic period, the Bathonian stage, approximately 166 million years ago, and hails from southern England. At first, the naturalist mistook Megalosaurus for a giant lizard about 20 meters or 65.5 feet. It was later concluded by Owen that it was no longer than 9 meters or 30 foot, standing on upright legs, and was a quadruped. Buckland himself considered Megalosaurus to be a quadruped amphibian, i.e. being an animal capable of both swimming in the sea and walking on land. However, he understood from the thigh bone head that the legs were not so much sprawling as held rather upright. The theory that carnivorous dinosaurs like Megalosaurus were quadrupeds was challenged by the findings of almost intact skeletons of Ozraptor spondylus, a large theropod. North American discoveries of large theropods, such as Allosaurus, confirmed that they were bipedal. Modern scientists were able to compare Megalosaurus with its direct relatives in the Megalosauridae clade, and gave a more accurate picture. They thought that Megalosaurus was about 6 meters or 20 foot, weighing about 700 kilograms, 1,500 pounds. It was bipedal, walking on stout, long and powerful hind limbs, though they were not as heavily built as its close relative, Torvosaurus. Its horizontal torso was balanced by a horizontal tail, and forelimbs were short but strong. 3 main digits on each limb bore long and sharp claws. Megalosaurus had a rather thick, large head, equipped with long curved teeth. The dentition shows the same combination, the Piatnitskysaurus. Megalosaurus was generally a robust and heavily muscled animal, and probably grew longer and stronger than Ozraptor spondylus. Benson claimed that Megalosaurus, though mid-sized, was still among the largest of Middle Jurassic theropods. After the discovery of Megalosaurus, any big meat-eating dinosaur whose fossils have been found in the Middle Jurassic rocks, especially those from Europe, have traditionally been regarded as megalosaurs. Scientists see Megalosaurus as a typically large carnivorous dinosaur. Since then, many large or small carnivorous dinosaurs from Europe and other parts of the world were assigned to the genus, creating wastebasket taxon as a result. In the 20th century, it was suggested that fossils found in the Middle Jurassic of England could have belonged to several, possibly not directly related, species of theropod dinosaur. It was easy to make a mistake in the classification of these big species, as they have similar build and appearance, but may represent a wider range of animals. Since the first discovery, the number of fossils in British collections quickly increased. The recovered bones mainly included a jawbone, pelvis, and hind limb bones, but no complete skeleton has yet been found. As many as 103 specimens from a minimum of 7 individuals were found in the Stonesfield slate quarries in the Taton Limescale Formation, although a vertebra and a skull were rare. About 30 teeth and bones of Megalosaurus were also found in the older Chipping Norton limescale formation dating from the earlier Bathonian. Although fossils from other areas have been assigned to the genus, the only certain remains of Megalosaurus come from Oxfordshire and date to the Middle Jurassic. It is believed that Megalosaurus lived in what is now Europe, in coastal woodland habitat during the Jurassic period, 201 to 145 million years ago. This theropod may have hunted Stegosaurus and sauropods. It lived alongside the theropods Cruxiceros, Iliasuchus, and Stratospondylus, and the sauropods Cardiodon, Cetosaurus, and possibly Cetiosauricus, as well as the pterosaur Ramphocelephus. In 1852, Benjamin Waterhouse Hawkins was commissioned to build a life-size concrete model of Megalosaurus for the exhibition of prehistoric animals at the Crystal Palace Park in Syndham. The statue remains there to this day. Hawkins worked under the direction of Owen, and the statue reflected Owen's ideas that Megalosaurus would have been a mammal-like quadruped. Therefore, it reflects the early ideas of how a typical theropod looked like at the time. The Megalosaurus's dentary bone, and a letter to Buckland from a Stonesfield slater, David Oliver, telling of great bones being found at the Slate Quarry, are part of the display at the Oxford University Museum of Natural History. Dinosaur teeth. Did you know that the dinosaurs could regrow their teeth? Unlike humans, dinosaurs could grow new teeth to replace lost or broken ones. This process could take up to 2 years. Each individual tooth grew in a socket of the jawbone, unlike in modern lizards, which have teeth fused to the bones. This socket allowed for lost teeth to be replaced by teeth below the roots. The dinosaurs' teeth represent 5 tissue types, similarly to their closest living non-avian relatives, such as the crocodilians, mammals, and amniotes, suggesting that these tissues first evolved in a common ancestor and has been kept ever since. Enamel. This is the hard coating on the outside of the teeth. It appears as a clear, thin, featureless band on the tooth surface. Dentine. This tissue makes up the bulk of the tooth and is characterized by long, thin, parallel tubules running throughout the body of the tooth. Cementum. This tissue covers the root of a tooth and is an attached tissue that forms part of the periodontium. It stabilizes the tooth in the socket. Periodontal ligament. This is a soft tissue layer between the cementum and the tooth socket. Alveolar bone. This is a spongy and look tissue that forms the tooth socket itself. Some adults went through thousands of teeth in their lifetimes. Rooted teeth were not very often found. Some fossils show unruptured teeth that never passed through the gum tissue while the animal was alive, so they show no feeding wear. The tooth formation period and replacement frequency rate are correlated to the feeding process and diet. The replacement pattern was similar to other reptiles. A replacement tooth grew in the dental lamina on the inside of the jaw before migrating upwards, reabsorbing part of the active tooth until it was ready to erupt and replace it. Plant-eating dinosaurs replaced their teeth very rapidly. Their teeth were flat to help with the extensive wear and tear caused by stripping and grinding plant material. An adult could have regrown as many as thousands of teeth in their lifetime. The rate of regrowth varied, but it is believed that all dinosaurs were able to regrow broken or worn teeth. Plant-eating dinosaurs, like the Diplodocus, turned over teeth at the pace of 1 tooth every 35 days. Based on histological studies, Patagosaurus would have replaced a tooth every 58 days, and Camarasaurus every 62 days. Meat-eating animals have less complex teeth than plant-eaters. Many theropods lost teeth while digging into their prey. The specimen of Megalosaurus jaw shows where new teeth had begun to grow, replacing the old ones when they fell out, as it dislodged or something else happened when it bit into its victims. Carnivorous dinosaurs replaced teeth more slowly due to the thick, reinforced quality. Tyrannosaurus rex's teeth were the biggest and strongest of all dinosaurs. It could take about 2 years to grow one back. But what do you think? What would happen if humans developed the same type of teeth? Would the dentist's workload be significantly lower? Patagosaurus. In the Middle Jurassic, around 179 to 177 million years ago, South America would have been part of the great southern landmass of Gondwana. The southern region of South America is known as Patagonia and is shared by Chile and Argentina. Patagonia is the largest region in Argentina and extends from the Colorado River in central Argentina to the Strait of Magellan, and from the Andes to the Atlantic coast. Patagonia, together with Antarctica, were part of a volcanic province. A layer of ash below the Canadon Asfalto geological formation in Patagonia is a proof of widespread extensional tectonism in the area. The fossil record of this formation represents the most complete known biota from the continental Middle to Late Jurassic of the Southern Hemisphere, and one of the most complete of the entire world. The region was abundant in typical Gondwana flora, including plants such as conifers, ferns, and equistales. The fauna was dominated by a diverse group of tetrapods, which were 4-limbed animals, by the aquatic amphibians to land-living turtles, mammals, and obviously reptiles such as dinosaurs. The only amphibian known to exist there was Notopatrachus, an extinct genus of frog. Turtles were represented by the Condorcellus. Mammals are known from a few genera, including Argentoconodon, which were a theromorph carnivore and capable of gliding animal. Asphaltomylos and Henosferus were early forms of land mammals. So far, in the Patagonia Plateau were discovered sauropod dinosaurs, including Volkimeria, Patagosaurus, and a potential third genus that is not yet named. Whereas Piatnitskysaurus and Condoraptor represent a group of megalosauroid theropod dinosaurs. Patagosaurus was discovered in the early 1970s in the Canadon Asfalto Formation in Patagonia. About 12 specimens were found together, 5 of them with skulls, suggesting that they lived and moved about in herds. The specimens were first described by José Bonaparte in 1979. For the fossil he erected the genus Patagosaurus, as well as its type species P. fariaceae. The generic name of Patagosaurus comes from the location of its find in Patagonia, and the fact that it is a reptile, the Patagonia lizard. The specific name honors Ricardo Farias, on whose land the initial discovery was made. Patagosaurus is known from many specimens, including at least one juvenile. The adult and juvenile exhibit the typical features of a sauropod: a long neck, small head, a long tail, and being quadrupedal. The only difference that juveniles exhibit from the adults is in regions like the mandible, pectoral girdle, pelvis, and hind limb. Otherwise, they display a similar anatomy. The skull of Patagosaurus is not very well known. It is assumed that its snout would be short, high, and broad, as a typical feature of most sauropods. Patagosaurus is similar to closely related taxa like Cetiosaurus and Volkimeria. More basal genera such as Parapasaurus and Amygdalodon, and more advanced sauropods like Diplodocus and Camarasaurus. The similar characteristics in these sauropods proved that there was still a connection between South America, Western Europe, and Africa, and they could freely travel between all these places. It has been estimated that it was about 16.5 meters or 54 foot long and weighed about 7.88 tons. Although some scientists argue that the dinosaur was much smaller. Patagosaurus had a long neck and walked on all fours. It was a herbivorous dinosaur that lived in forests and other green areas, as it had to eat many plants a day to maintain its large physique. The teeth of Patagosaurus are similar to more derived sauropods, such as Amygdalodon, but the rest of Patagosaurus' skeleton is more advanced and represents that of Cretaceous. The neck vertebrae have some kind of undivided spines, and the back vertebrae have shallow cavities rather than the deep hollows of later sauropods. These simple backbones are largely what defined the Cetiosauridae. However, the hip bones and the tail are different from its European relative. A fine mounted skeleton of Patagosaurus stands in the Argentine Museum of Natural Sciences in Buenos Aires and is dedicated to the pioneer Argentinian Bernardino Rivadavia. This discovery makes Patagosaurus the best known of the early South American sauropods. Ozraptor. Sometime in 1966, 4 12-year-old schoolboys from Scotch College went to the Bringo Railway cutting, about 20 kilometres or 12.5 miles east of Geraldton in West Australia. On that day, Stephen Hinckliffe, Peter Peebles, Robert Caldwell and Trevor Robinson hoped to collect some fossils in the Kalalura sandstone. It was a very successful visit for the schoolboys who found a specimen of the leg bone, exactly the distal end of a left tibia. They showed it to Professor Rex Pryder of the University of Western Australia, who made a cast and sent it to the experts of the British Museum of Natural History in London. The scientists thought it likely belonged to an extinct turtle. However, about 30 years later, when John Albert Long and Ralph Molnar re-evaluated the bone, they classified the fossil as the shin bone of a genus of possibly a belisauroid theropod dinosaur. The schoolboys who found the specimen were probably unaware of their discovery and its significance to the history of Australian dinosaurs. The fossil is the first Jurassic theropod skeletal material from Australia, and the first Western Australian dinosaur to be formally named, apart from an ichnotaxon and the oldest theropod bone from the continent. The closest theropod both in age and geographical proximity in eastern Gondwana is Cryolophosaurus eriotai from Antarctica. It was argued later that the characteristics are actually not limited to just the abelisaurs, and thus Ozraptor can be classified as Theropoda indet, meaning that it is still inclusive. Ozraptor represents a new taxonomic group of theropod dinosaur that was relatively developed for its age. The Bringo Railway cutting area comprises the ascending Kalalura sandstone, which is 500 millimeters thick, Bringo shale at 2.1 meters, and the Numarakara limestone up to 10 meters thick, and of course, the Corregina sandstone. This geologic formation dated to the Bajocian in the Middle Jurassic and known to be abundant in fossilized wood, bivalves and ammonites. The only fish known from the Jurassic period in what is now Australia are all non-marine, primitive ray-finned fish that were distributed widely in that period. Over the years, there were several discoveries of some fossils of the rare reptilian bones, including an isolated plesiosaur vertebra and a possible paddle bone from a plesiosaur. Australian dinosaurs are known mostly from scant and rare articulated remains of the early Cretaceous age in Victoria, New South Wales, South Australia and Queensland. The only Jurassic dinosaur so far described are the partial skeleton of the sauropod Rhettitosaurus brownie from southern Queensland, and a report of a probable sauropod caudal vertebra by Long in 1992 from near Geraldton, Western Australia. Together with Rhettitosaurus and a belosauroid, Ozraptor is amongst the oldest known Australian dinosaurs. There are probably more Jurassic animal fossils waiting to be discovered. Who knows? It could be you, or another group of school children, who discover the next dinosaur's bone, or another extinct organism's fossil. Although Ozraptor is only known from a part of a leg bone, the paleontologists were able to recreate the image of the animal and deduce that it was a swift-footed carnivore theropod. Any existing Ozraptor's pictures are created and illustrated based on very little information. Its size is considered to be around 9 foot or 2.7 meters long, with an unknown height. The weight of the animal is evaluated to be around 100 pounds, being 45 kilograms. Ozraptor could hunt on small animals, hatchlings, or any other animals that came too close to be resisted. It is assumed that Ozraptor's legs have been adapted for fast running, and it resembles that of a basal dromaeosaur that existed in North America in Cretaceous times. In 1998, Long and Molnar named and described the type and only species, Ozraptor subotai. The etymology is derived from Oz or Aussies, a colloquial use for Australians, and a Latin raptor, robber or thief. The specific name honors a fictional character, the swift-running thief and archer Subotai from the movie Conan the Barbarian. The Ozraptor is not classified as a raptor. Raptors are actually a different family of theropods that existed from the Middle to the Late Cretaceous period. These raptors were characterized by the assumed coat of feathers and curved and oversized claws on their hind feet. In Middle Jurassic times, Australia was at the far end of the southern arm of the C-shaped supercontinent, Pangaea. As the Jurassic continued, the first signs of the breakup of Pangaea began to show as the tectonic plates were reactivated and began the process of separation. During that time, Australia was still at high latitudes, with winter nights that could last for months. The plants that herbivorous animals lived on were evergreen, only going into dormancy during times. However, even during the dark winters when sunlight was not available for photosynthesis, there was still enough food for all animals to survive the whole year round. These videos take a very long time to create. If you would like to support the channel and assist in improving it, then do please subscribe and give us a like, and consider joining our Patreon, links in the description.